Alright, hello, welcome to another beautiful lesson in Algebra 2. So today we're going to be talking about factoring. So I want to begin with just some general context about factoring and factors, and then we will go into more about specifically factoring polynomials. So first, let's go back to the definition of a factor or factors. So a factor is a number or a term that you would multiply to get another number or term. So in this case, the factors here for 15 are the numbers that we would multiply to get 15. So you may have had a factor tree from previous math classes where you would say, okay, the numbers I would multiply to get 15 are 3 and 5. And I can't divide anything more, so 3 is just 1 times 3, 5 is just 1 times 5. So these are my two factors, or I can write this as 3 times 5 equals 15. So again, these are my factors, 3 and 5. We can also start to add in variables and factor those as well. So in this case, we have 6, which is 2 times 3. And we can't factor that anymore. For x squared, remember our definition of an exponent, it tells us how many times we multiply the base. So x squared means x times x. So in this case, the factors of 6x squared, we can write as 2 times 3 times x times x. These are my smallest factors. And I can write variations of this, like I can write 2 times 3 times x squared, because when I multiply I still get 6x squared, or I can write 6 times x. Those are factors because when I multiply I still get 6x squared. Okay, so just be aware of that. Sometimes we're not looking at the smallest, most basic factors. Sometimes we're just looking at the fact that is it a possible factor. So I can multiply 6 times something to get 6x squared. I can multiply x squared times something to get 6x squared. Alright, and then we have one more example. So let's say we have 8x squared. Again, we would break this down into its factor using a factor tree. Now we have a case where we can keep factoring. 4, we keep factoring, that's 2 times 2. And then let's not forget about the x cubed. Again, that's first we can say x times x squared. Then we can break down the x squared into x times x. So we have 3 more factors, x times x times x. So the 2, 2, 2, and then 3 times 3 times 3. These are all factors of 8x cubed. And like I said before, we can write this as variations. So 4 is also a factor of 8x cubed because we can write 4 times 2 times x times x times x to get 8x cubed. Or we can write 2 times 2 times 2 times x cubed equals 8x cubed. So any variation of this still works the same. We're still looking at numbers or terms that we multiply to get 8x cubed. Okay, so feel free to pause the video here and take a look at this to make sure that you are clear about factoring and that you have convinced yourself that this is the case, this is true for factors. Now let's look at some polynomials here. So we're factoring polynomials in the lesson for this week, which just means we're breaking polynomials up into the things that we would multiply to get them. So it's essentially the opposite or the inverse of multiplying. So you're going to see that you can always multiply to check your work here. And excuse the beeping. I should have said that from the beginning. My fire alarm still hasn't been fixed. It needs a new battery, so I apologize for the beeping. Okay, so we have 2 examples here. We have x cubed minus x squared in number 1. So this first one, when we're trying to factor multiple terms being added or subtracted, the way we would do this is to first we could separately look at the terms. So I can look at just the x cubed. So that will be equal to x times x times x. Those are the simplest factors. And then x squared would be x times x. Okay? So now we want to compare these two. So x cubed is 3x's being multiplied. X squared is 2x's being multiplied. Well, what do they have in common? They have 1x, that's the same. And then they have a second x, that's the same. So x times x is x squared. This we call the GCF, or the greatest common factor. So it's the largest similar factor. So the largest factor that they have that's the same. So I can't just say x, because once I take away the x, I still have 2 x's left. So I have to consider x times x, which is x squared. Again, feel free to pause here, think about it, convince yourself that this is true. So I'm just going to go about looking at the greatest common factors for all of these problems I have here. And number 2, you're looking at what do 3x squared and 3x have in common. So maybe you see it right away. If not, let's break it down. So 3x squared, that is 3 times x times x. 3x is 3 times x if we break it down into its factors. What do they have in common? They both have a 3 and they both have 1x in common. So if we multiply 3 times x, we get 3x. So here, our greatest common factor is 3x. Okay? Because they have a 3 in common, they both have a 3, and they both have an x. 3 times x is 3x. Feel free to pause, convince yourself. The next one, 8x squared minus 16. So here we have a term with a letter and then just a regular number. So here, if we were to factor this polynomial, looking at just the GCF for now. So our GCF, we need to determine, so 8x squared, 8 can be broken down into 2 times 2 times 2. You can multiply that, check your work, you can see that that is equal to 8. And then x squared is x times x. 16 will be 2 times 2 times 2 times 2. Again, multiply that out if you need to. 2 times 2 times 2 times 2, and see that that's 16. So these are all the factors. What do they have in common now? So both 8x squared and 16 have a 2 in common. They both have a second 2 in common. They both even have a third 2 in common. Okay, so our GCF here, have you guessed it, is 8. Oh, let me move this up a bit. Alright, and then finally, I'm going to do one more example. So, feel free to pause and try it on your own first before I go over it if you need to. So 4x cubed, I want to find the greatest common factor. So I'm going to write 4 times is 2 times 2. X cubed is x times x times x. For 8x is 2 times 2 times 2 to get the 8, and then another x. Alright, what do they have in common? Well, they have 1 2 in common. They have a second 2 in common. Well, this one just has x's, and so this x, one of the x's they have in common, there's nothing else that they have in common here. So they have 2 times 2 times x in common. That is 4x. That's the greatest common factor. So in the PowerPoint, when you saw GCF in some term, this is what I was doing. I was looking at the terms in the parentheses and deciding, okay, these two things have this term or number in common. So that's what we call the GCF, or greatest common factor. Alright, so we're going to end today's video with just doing a practice problem that we're going to factor. This may or may not be a problem already in the PowerPoint for this week's lesson. I'm not sure, but we're going to go over it. So there are different problems that we had. So I'm going to do an example. I'm trying to think. Do I want to do an example of the... Let's do an example of the factoring by grouping. I don't have much time. Squared. Alright, so we're going to start with this polynomial, x cubed minus x squared plus 2x minus 2. If you would like, you can pause it here and try to figure out how to factor it by grouping on your own. Alright, so let's get started. So step 1, we put a parentheses around the first 2 terms and the last 2 terms. That's step 1. We're grouping the first 2 terms and grouping the last 2 terms. Next, this is where we do or find the GCF. So between x cubed and x squared, what do they have in common? Where this has 3 x's, this has 2, so the greatest common is 2. What's left, what we would do is we would divide each term by what our GCF was. So that will be x cubed divided by x squared, which is x. And then x squared divided by x squared, anything divided by itself is 1. Bring down the minus sign. Bring down the plus sign here. Then over here, same thing, find the GCF. 2x and 2, what do they have in common? Well, they have 2 in common. We're dividing out 2, so 2x divided by 2. We're left with x. 2 divided by 2, again, anything divided by itself is just 1. Bring down the minus sign. Our next step is to write the factors out. So if we have anything in common, we can keep dividing it out. So we have an x minus 1 in parentheses here, and then an x minus 1 in parentheses here. Well, that's a common factor as well. So we have x minus 1, bring that down. Then our next part of the factors, we just combine the GCFs and add them together. X squared plus 2. And then I labeled in the PowerPoint, I just labeled what my GCFs were so that I know what I'm combining here. So my final answer here, if I'm trying to factor x cubed minus x squared plus 2x plus 2, I'm going to say x minus 1 times x squared plus 2. So these are my factors, and I have factored completely because I can't factor this anymore, and I can't factor x squared plus 2 anymore after I check that. To check your work, if you're like, I did all the work, I think I did it right, but I'm not sure, you can always check your work by multiplying. So I'm going to FOIL x cubed plus 2x minus x squared minus 2.